So what are phasors? Phasors basically they are what? Rotating vectors. These rotating vectors can be of anything. They can be of current, they can be of EMF. Although sir, we know EMF and current are not vectors, but still they were varying with time, right? So basically we can represent those quantities with the help of this particular thing, with the help of this particular concept, which is called as the phasor diagram and all, right? So we can represent any phasor which is basically representing sinusoidally with time, and we can assume that this phasor, this vector is over here, it rotates with time, so that implies that at some time instead it will become like this as well, at some time instead it will become like this as well. So can you see this thing is rotating, right? Are you getting my point? At some time instead it will come over here. So everybody can feel, imagine the rotation of this particular phasor, right? Is this clear? So basically this is a phasor, and basically phasor is basically if you draw a vector and you rotate it about a fixed particular point, and generally that point is tail, it's tail, right? So this is particularly called as your phasor diagram. Now suppose if um, there is an EMF which is equals to E naught sine omega t. I want you to draw a phasor of basically this one. I'll tell you about the phase as well, what exactly is the phase and all. Now suppose if they this is given E equals to E naught sine omega t. So what exactly I will do? Okay, so what exactly I'll do, I'll draw this thing. At t equals to 0, the phasor will be over here. I'll tell you the reason after a short while. Okay. So suppose E equals to E naught sine omega t, then always remember at t equals to 0, this phasor should be parallel to the x-axis. I'm trying to make it as short as possible because those people who have done SHM, they already know, and those people who are new, they can just at least grab the basics of what exactly is phasor, right? So now this vector is rotating anti-clockwise. Please remember, rotate it anti-clockwise. Rotate anti-clockwise. General case. Generally, we rotate it anti-clockwise when omega is positive. When omega is positive, omega is basically what? The angular
frequency.
Angular frequency in the case over here. In the case of the SHM equation, this angular frequency of the whatever quantity is there, in the case of phasors it becomes angular velocity of the rotating vector. Is this clear? Same omega. So now tell me, if I have drawn this at t equals to 0, and if someone tells me what will be the diagram at t equals to t, then what will I do? If someone tells me what will be the diagram at t equals to t, control C, control V. Please, you can draw this thing in the next line, no problem. So suppose if I want at t equals to time t, where exactly is this phasor? So will this phasor come over here? Yes or no? After a certain time at t equals to t, this phasor will rotate by a certain angle, right? At t equals to 0, it was over here. At t equals to t, it rotates by a certain angle, right? Can anyone tell me what is this angle? Can you see this theta will be basically equals to what? Can you see it is moving with, rotating with a constant angular velocity. So theta is basically omega multiplied by time, right? So basically this is your theta. Always remember, on the diameter of this particular circle, or basically the length of the phasor, the length of the phasor will, I'll do this thing for you. Just give me 2 minutes. Please remember, whenever you have a phasor diagram, and if you wanted to relate it with the help of this E equals to E naught sine omega t. So can you see whatever is the omega is over here is basically what the angular frequency, right? Yes or no? So in the case of phasors, omega becomes what? Omega becomes what? The rotating or the angular velocity of the rotating vector. I'll try to explain you once again. And this E naught, which is basically what? What was E naught? E naught was basically what? Everyone? Was it the peak value of EMF? So in the case of phasors, this E naught will become what? The length of the rotating vector. Is this clear, guys? So can you see the radius of this particular thing is how much? Can you see the radius of the circle, or basically the length of this phasor is basically equal to E naught? So this is also E naught. Is this clear, guys? इतना समझ में आया क्या?
Yes, sir.
Okay. Always remember the phasor for E equals to E naught sine omega t will start from, the phasor for E equals to E naught will start, E naught sine omega t will start from positive x axis. So guys, let me explain you once again. Everyone understood what exactly a phasor is? Phasor is basically a rotating vector. That vector can be of anything. We can make it for current, we can make it for potential difference, we can make it for EMF, anything. It's just a representation of this to this, right? Now when we write E equals to E naught sine omega t, we all are aware of this particular thing, that this omega t is basically what? Omega is basically the angular frequency of the alternating EMF, right? Yes or no? And this is basically the peak
Yes,
value
sir.
of alternating EMF. In the case of phasors, the same omega which you have written over here, that same omega behaves as what? The angular velocity with which the vector is rotating. And this E naught becomes what? The length of that rotating vector. So always remember, this E naught will be the length of this rotating vector. So can you see E equals to E naught sine omega t when I have given? That implies it will always start from positive x-axis. I'll tell you the reason a little bit later. Okay. Now, can you see over here? Suppose, if I drop a perpendicular on y-axis, if I drop a perpendicular on y-axis, if this angle is theta, this angle is also theta. Yes or no? Alternate interior angles. And can you see a triangle forming over here? Let's name it as P and let's name it as M. Okay. So can you see a triangle over here? OPM. This angle is theta and theta is basically equals to omega into t, right? This is E naught. Can anyone give me what is the value of OM from here? Will OM be equals to, what will be the value of OM?
E naught sine theta.
E naught by sine.
OM is basically OP is equals to sine of theta. So I can write OM is equals to OP sine theta. Now please remember, what does this OM represent on the y-axis? What does this thing represent? This represents the instantaneous EMF. This thing represents the instantaneous EMF on the phasor. So basically this is E. OP was equals to E naught and sine theta was equals to sine omega t. So can you see from this diagram as well, you are able to get this equation. So basically this equation can be represented as this diagram. Are you getting my point? So to understand how
Yes.
exactly this function works, people have devised this method, which is basically called as a phasor diagram. Is it clear? Is this first thing clear, guys? E equals to E naught sine omega t. If you keep on varying this time, this factor, this phasor will keep on rotating, like, yes or no? Acha, at time t equals to capital T by 4, where exactly will this phasor reach? After a 1/2 time period, only 1/4 the time period of the whole thing, where exactly this phasor will reach? This phasor will it reach over here? Yes or no? So always remember how this thing is free, oscillating. This thing is rotating. Exactly the same thing. When this goes from mean position to extreme position, this goes from the positive x-axis to the positive y-axis. When that comes from the positive extreme to the mean, then from positive to extreme, the second quadrant. Then when it goes to the mean to the negative extreme, so then mean to the negative extreme, and then negative extreme to mean position again. Is this clear? So when one complete oscillation completes, here one complete rotation will get complete. Are you getting my point? That is why we have taken omega as same for both of them. Is the reason clear, guys? Everyone? Navina, Arya, are you?
Yes,
Is this
sir.
clear? Is this
Understood.
concept clear? Okay.
Yeah.
So now the same thing goes for another thing. If I want to represent the general equation E equals to E naught sine of omega t plus phi. I have not come to you, I have not made you understand what exactly is phase. I'm just making you relevant with the equation, right? Now what is this E naught? E naught is again the peak value. Omega is again basically what? Omega is basically again what? The angular frequency, and phi is basically called as the initial phase, if you remember, right?
Yes,
Everyone?
sir.
So ab dekho, basically what does that particular thing mean? Suppose if I have this again two axes I have, and why am I drawing it like this? See, so now guys, can you see over here at t equals to 0, if I try to draw the diagram? So please remember, in this equation and that equation, what was the only difference between them? E equals to E naught sine omega t and E equals to E naught sine omega t plus phi. What is the only difference between them? That initially it had certain phase, right?
Yes, sir.
And I told you this particular thing, that omega t, whatever is written in front of this omega t is always meant, this thing is basically what? The phase, right? So can you see this omega t is nothing but the angle which it makes with the positive x-axis, right? Ayana?
Yes, sir.
So basically, what is this phase thing? In the case of phasors, what is this phase? Phase is just the angle which the phasor makes with the positive x-axis. Okay. So basically, suppose at t equals to 0, initially it has certain phase. So you can never draw it, combined with the x-axis. You will never ever draw it, like this. Never ever. This will become wrong. Okay. You can draw it after some time, but not now. So at t equals to 0, whenever there is an initial phase is present, then what exactly will you do? You'll draw that phasor at a certain angle, which is basically called as the initial phase. And then you will start rotating it. So are you understanding it, guys? What exactly is the initial phase? Initial phase is basically just the angle. So at t equals to 0, the phasor is over here. Can you see, if I try to get some instantaneous value, I can get some instantaneous value. If this is phi, this is phi, and if I say this is a naught, another initial value, or if I say a naught ki jagah pe, if I write, what can I write it? Let's say this is a dash, suppose, or e dash, because we are talking about EMF, right? So this is the initial value, e dash, instantaneous value of EMF at t equals to 0. So can you see again a triangle can get formed? Everyone, can you see this particular thing? This is basically e dash, this is basically e naught, and I can write directly e dash is equals to e naught sine phi. Can I write it directly? Can I write it directly? So always remember, when the phasor will have this a general equation, that will mean that at time t equals to 0, it is not starting from 0. It is starting from e dash value. Is this clear? Guys, you understood what exactly initial phase and what a phase means, right? Anna? Phase is basically just the angle. So at t equals to 0, the angle which the phasor was making with the axis is basically how much? Phi. If this is phi, that is phi, and you can calculate the whole value. Is this clear? You can make a triangle like this. Shall I draw the triangle as well? I have drawn the triangle. Please draw it. Now what will happen if you rotate it a little bit? Let's say after a certain time t, it comes over here. Where was it initially? Initially it was over here, right? At t equals to 0, it was over here. This angle was phi, right? At t equals to t, it came over here, right? It rotated by certain angle. Can anyone tell me what is this angle by which it is rotated? It is rotating with
Omega t plus phi.
So omega t. So now what is the total phase of this vector? Can you see? Omega t plus, what is the phase? Can you see? Omega t plus
Phi.
Now are you getting my point, guys? So here now the angle, or basically the phase, becomes omega t plus phi. So this angle is also omega t plus phi. This is the instantaneous value. This is the e naught. And can you see, when you solve it again, you will get e equals to e naught sine omega t plus phi. Everyone understood what exactly do you mean by phase? Phase is basically just the angle. So basically this angle which it makes with the positive x-axis. Is it clear? Everyone, is it clear?
Yes, sir.
Now, can anyone tell me the third one? If I have E equals to E naught cos omega t. So what is E equals to cos omega t? Can you see? E equals to E naught cos omega t is nothing but E equals to E naught sine omega t plus 90, right? So basically it's a phasor which has the initial phase of 90 degree. That implies this phasor does not start over from the mean position. It starts from the it starts from the
E dash.
basic a dash. No, a dash, so it was this, no? E dash, what will be the value of E dash when this angle becomes complete? Can you see? E dash and E naught will become equal at that time.
Yes, sir.
So if this phasor rotates like this, then so this is your at t equals to 0, the phasor is over here, right? At t equals to 0, the phasor is over here. Now at t equals to t, if you try to draw it, then this phasor will come somewhere over here. Are you getting my point? I'm still rotating it anti-clockwise. Can you see over here? So this angle will become omega t. This was the initial position, and now again you'll draw this thing. Always remember the instantaneous value will be on the y-axis. It can be positive, it can be negative, does not matter. But still, when you do it, it will become. Can you see? E and E naught, and this angle is omega t now. Can anyone give me a relation between these two angles? Guys, can you give me a relation? Can you see E equals to E naught cos omega t? This is the base, this is the hypotenuse. So always remember, phasor is nothing just but a rotating vector. If you can just draw this to this, then your problem is solved for anything. Is this clear? Is this clear, guys? थोड़ा बहुत समझ में आया phasor? And this is what we require as of
Yes,
now.
sir.
है ना? Now, if I try to analyze this thing, the phasor, please write the next heading, phasor analysis of various circuit elements. So now I'll draw the phasors in this case. Now, first case is basically when you connect an alternating EMF across a resistor. You remember those cases? First I connected across a resistor, then I connected it across a. So suppose if this was the case again, only a single resistor is there, E is equals to E naught sine omega t, and let's say the current in this case is how much? What was the current, guys? Do you remember? Anyone? The current was equals to I naught sine omega t, right? When we solved it, you got these equations, right? अरे किसी को याद है कि भूल गए हो सर?
Yes, sir.
So if I try to draw the phasor in this case, then see how the phasor will look. Guys, it's not necessary to draw the diagram again, but just write those equations. You know, these equations are very important. So basically, I'll draw two different phasors. I'll draw one phasor of EMF. So can you see the black one? This phasor is basically of EMF. It will rotate with the same angular velocity. Can you see? Both phasors have equal angular frequency, but different value of I naught. Different value of peak value, right? So can you see the red one as well? Guys, can you see me? Okay. Suppose this is your phasors. They both are lining like this. One phasor is a little bit big in magnitude and one phasor is a little bit smaller. So can you see, when they both will rotate with the same angular velocity, they always will be in the same phase. I try to
Yes,
rotate
sir.
them. So they both will rotate like this. Is this clear? So
Yes.
at any
Yes, sir.
general
Yes, sir.
instant, if I talk about, where is it? If I talk about this diagram is when at t equals to 0, right? अरे हाँ है ना? So at any particular instant, control C, control V, these phasors will become something like this. Achha, don't think like, So can you see, guys, at time t equals to t, both the phasors would have been rotated by the same angle. Ayana, is this clear, guys? Now you understood exactly what is happening. And how will you give the
Yes,
value of
sir.
I naught? You know how to give the value of I naught and both of these things, right? Is this clear? Please remember, in the case of across the resistors, both the phasors of E naught and I naught. E naught and I naught is basically the current, right? And always we represent with the help of peak value. So both the phasors, it's not necessary peak value. We can write RMS as well, but we'll do it that later on. So both phasors of E naught and I naught have, or in spite of have, rotate in the same phase. Please remember, whenever I'm talking about EMF, EMF is basically what the whole source's EMF was across the resistor, right? So always remember, whenever I talk about this EMF over here, that is not exactly the EMF of the source. This is the EMF of the, this is the potential difference across the resistor, right? I made you write it like that only, if you remember clearly, right? Yes or no?
Yes,
Please
sir.
draw it. Now the second thing which we'll be doing, always remember both phasors rotate in the same phase at all times, so they will be always parallel to each other. And always remember, you can say this particular thing. Do you remember why did I took it this particular on y-axis? So it's basically called as, you can write somewhere, idhar hi likho, the projection of these phasors on the vertical axis represents the instantaneous value. Is this clear? Is it clear, people?
Yes,
Now,
sir.
shall I connect a capacitor? If I connect a capacitor, so can anyone tell me what was happening in the case of capacitor? In the case of capacitor, the current, if the EMF was E equals to E naught sine omega t, so the current was leading or lagging?
Leading.
Reading.
Leading by a phase difference of,
Leading.
Pi by 2.
very good, pi by 2 radians. Is this clear? So when I'll try to draw the phasor of this particular thing, how exactly will it look? How exactly will it look, guys, if I try to draw a phasor of this thing? I'll always draw two different diagrams. One diagram will be at t equals to 0 and one diagram will be at t equals to t, general time, right? So can anyone draw these phasors for me? Let's draw the phasor for E naught with black. Yes, tell me, where exactly will this phasor lie at t equals to 0?
On the positive x-axis.
Very good. So on the positive x-axis, I have made it lie. Can you see E naught was lying on the positive x-axis? Now let's say red is basically the current. So yeah, where exactly will this thing lie? Acha, if I try to draw a circle of this particular E naught, will it look like this? If I try to draw the circle of E naught, although it's not exactly a circle which I am drawing, but actually it is a circle, है ना? मन की आंखों से देखे हुए, so you will exactly see a circle over here. Anyways, now what is the value of where exactly this I naught will lie?
On the y-axis.
On the positive y-axis. So this is basically the phasor of I naught, and I naught will rotate in this circle. Okay, so I'll do this. Good morning, sir. People, can you see me?
Yes, sir.
Everybody able to see this? Can you see the EMF? This is the black pen,
Yes.
black, and this is the red one, current. So basically, EMF is like this, I is like this. Now, can you see the angular velocity of both the vectors is same? Both the rotating vector, the angular velocity is same, no? Can you see omega same, right? So when they will rotate, they will always rotate like this. Can you see over here, when this rotates, this also rotates by the same angle. So when this rotates by an angle omega t, this also rotates by an angle omega t. So both will rotate together. Can you see over here? Can you see this constant phase difference of pi by 2 is always maintained? The current is always leading, right?
Yes, sir.
Okay. So here, when I'll try to draw this E naught will go like this. And perpendicular, let's say if I say E naught moved here by an angle of omega t, then what will this guy do? I naught will go like this. I may not be able to draw it properly, but can everyone see this particular thing? Can you see I naught also rotated by the same angle omega t, but this constant phase difference
sir.
of 90 degrees is still there.
Mm.
Is this clear, guys?
Yes, sir.
Shall I draw another circle for I naught and okay? Circle should be of the same size, please remember. In both the diagram, these circles should be same. So थोड़ा अपना diagram try to make it accordingly. Now it's almost the same, na? Is this clear, guys? Everyone understood exactly these rotating phasors and all. And how will you give the instantaneous value? You'll draw a perpendicular on the vertical axis. You'll draw a perpendicular on the vertical axis, and just find out this value. If it comes in the positive direction, then positive. If it comes in the negative direction, then negative. Is this clear? Is it clear?
Yes, sir.
Sir.
So always remember, in the case of capacitor, the current will lead the EMF by a phase difference of pi by. Now third part, if I have an inductor across an inductor, if suppose if you have an inductor connected across an alternating source. So do you remember, in this particular case, if E was equals to E naught sine omega t, then the current was basically I equals to I naught sine omega t minus pi by 2, right? Yes or no?
Yes, sir.
So basically now can you people draw the diagrams? I don't want to draw them. Can you people draw it, please? You please draw it yourself. I don't want to draw it now. what will be the only difference between the previous diagram and this diagram? Now the current which was leading earlier, that current will now lag. So can you see I made it pi by 2 phase down, and here also. You need to draw it again. Is this clear, guys? These angles. Is it clear? Current here lags by an Is it clear, guys? Now, shall I connect all three of them in series? In spite of connecting, acha, when you connected an capacitor and an inductor in series with each other, it started oscillating, right? Do you remember the energy started oscillating? LC oscillations, EMI chapter, right? Hello.
Yes, sir.
Actually, if you are done with this thing, please write now. The RLC series circuit across alternating EMF source. Basically, what exactly am I doing in this case? I am having a resistor, an inductor, and a capacitor in series with each other across an EMF source. Let me draw it a little bit more. I'm making the diagram a little bit so that it will be much more clearer to you. And this this derivation is important as per your school point of view. So what will you do, guys? Let us consider a resistor of resistance R, comma, inductor of self inductance L, and a capacitor of capacitance C in series with each other, connected to an alternating EMF source. So this should be your opening statement, guys. And I think next time onwards you are capable of writing this statement, right? What is the EMF of this particular thing? What is the EMF of this source? The EMF of the source is E equals to E naught sine omega t. Let us assume, guys, let us assume that in this particular case, the I is equals to I naught sine omega t plus phi. So can you see, guys, over here, I am assuming that this phi is positive, and if phi is positive, that implies the current is leading, right? So can I see this particular thing? If I compare both of them, can I say what is phi? Phi is basically the phase difference with which the current leads the EMF. बाप रे कितना सारा भाई, ये खोल इसको, थोड़ा परफ्यूम हो गया. Current leads the EMF of the source. So this is the phase difference with which the current leads the EMF of the source. Is this clear? Please remember here phi I am assuming is to be what? Current leading the EMF of the source, right? So if phi is positive, that implies current leads EMF.
Yes,
And
sir.
if phi is negative, that implies current lags
Lags.
from EMF. Is this clear? Is this clear, guys? ये थोड़ा ध्यान रखना है ना. This is the convention which we generally take. So you'll write this as statement. If phi is the phase difference with which the current leads the EMF, then current की E equals to E naught omega t and I equals to I naught sin omega t plus phi. Is this clear? Is this clear, guys? Now, do you remember whenever you have an EMF across this particular thing, this EMF, since they are in series, current will remain the same, and what will divide? In series,
EMF.
EMF will divide. So let's say this EMF, this EMF, please remember, this EMF, it divides into three components across the whole three circuits. Let's say the potential difference across the resistance is VR. Let's say the potential difference across the inductor is VL, and let's say the potential difference across the capacitor is VC. So since the EMF of the source divides among R, L, C, then can I write this particular thing? The EMF of the source is equals to VR plus VL plus VC. Can I say this?
Yes, sir.
Since that instantaneous EMF was dividing across all three of them, then can I say this particular thing? This is how we derived for series combination Ohm's law. If you remember R1 plus R2 plus R3, किसी को याद हो तो, right? Is this clear, guys? Now let's come to the analysis very quick. What was the current in the circuit? Guys, what was the current in the circuit? The current in the circuit was same for all of them, right? So I equals to I naught sin omega t plus phi. Now, what is the phase of this phasor? What is the phase of this current? Guys, tell me. What is the phase of this current?
Phi.
Huh?
Phi will
I'm
be
not
the phase.
Phase of this current, omega t plus phi. Phi to in initial phase, right? The phase as of now is basically, I told you, whatever is written inside the bracket. So the phase of this thing is how much? Omega t plus phi, right? If I draw a current, will it look like this? At initial phase phi, will it look like this?
Yes,
So
sir.
can you see over here, in the case of resistance, the potential difference across the resistances also should be in the same phase, right? So can I write VR is also in the same phase as of, VR should be also in the same phase as that of the current, omega t plus phi. If I is basically this, then R should also be this only. That implies VR should be like this, in the same phase at t equals to 0. At t equals to 0, you don't need to draw this omega t thingy. At t equals to t, if you want to draw, then you have to draw it. Is this clear? And this will be VR naught. Please remember, Well, what is this VR not? Guys, what is this VR not?
The peak value of EMF for the
Exactly.
resistance.
Peak value of potential difference across the resistor. This VR naught may be equal to E naught. This VR naught may not be equal to V naught. Are you getting my point? So ये कुछ भी हो सकता है. So this thing is clear for resistance. You know, these two equations when we made, this is clear, right? For capacitance, if current is basically this, if current is equals to I naught sine omega t plus phi. Sir, why are you taking the current as same for all of them? Because they are in series. Simple logic, है ना? So can you see here also the current which I took was in the same phase. Here it should be also in the same phase. Then what should be VC then? VC should be equals to VC naught into sine of omega t plus phi. Now, can anyone tell me in the case of capacitor what was leading and what was lagging?
Current was leading.
Current was leading. So, kabhi, if the current phase is basically how much? This much. Current phase is basically omega t plus phi. Then the capacitors in the potential difference phase will be basically pi by 2 phase piche.
Yeah. Yes.
Can you see over here? I made minus pi by 2. Why did I write my minus pi by 2? Because current leads EMF, or EMF की जगह पे you can write potential difference across capacitor, है ना? Or you can say the potential difference across capacitor lags by current by a phase difference of pi by 2. So can you see, because of this lagging, since we were taking the reference over here and from this reference we wanted to derive VC, so can you see I lagged it by a phase difference of how much? When I am lagging it, then I need to subtract the phase, right? So is
Yes,
this clear? For capacitor, oh sorry, for capacitor C. Are these two equations clear to you? Similarly, for inductor, L, if the current again is same, then can anyone tell me what will be the equation for VL naught? You know, VL naught into sine of t plus phi
plus pi by 2.
Kyo? Reason?
Because for inductor the EMF leads current.
Exactly. For inductor, the EMF leads the current, or basically the current lags, right? If the current is lagging by potential difference, then the potential difference is leading by pi by 2, right? So hence plus pi by 2. Is this clear, guys? Are hi na? Hi na, guys.
Yes, sir.
Yes, sir.
Can I solve this a little bit more? Can you see it is sine of omega t plus, suppose omega t plus phi is in first quadrant. If omega t plus phi is in first quadrant and if you are subtracting 90 degree from it, then can you tell me what is, in which quadrant will this thing belong to? Omega t plus phi we are taking as one single unit angle, right? So will it become fourth quadrant? First quadrant minus 90 degree, it will come back in the fourth quadrant, right? And
yes,
sine
sir.
is negative in the fourth quadrant, so I can write minus of VC naught cos omega t. You don't need to remember this. I'm just doing it for solving purposes only. And similarly here, what will I, this thing become? I'm not writing the reason for this. Can you see it is some angle plus 90? It will come in the second quadrant and sine is positive, so it will become plus cos omega t plus. Is this clear, guys?
Yes,
So
sir.
now you have the equation for VL, now you have the equation for VC, and now you have the equation for VR, right? Guys, do you have the equation for VL, VC, and VR?
Yes, sir.
Now we'll try to use the knowledge of phasors, which we already did. Can you draw all these vectors together. Guys, can everyone draw all these vectors, all these phasors together? So I'll draw a very big diagram. Are you done writing till here, everyone? Guys, are you done writing till here? Done?
Yes, sir.
Now, can anyone tell me where exactly the current was? The current was like this. Can you see what is the initial phasor of this thing? What is the initial phase at t equals to 0? I'm drawing the whole thing. What is the initial phase of this thing? Phi, right? Or guys,
Yeah.
if
Yes,
you
sir.
don't want phi, let's make it omega t plus phi, okay? So that we'll draw it at, let's say, any general time. If I draw it on any general time, then can anyone tell me what will this be? This angle will now become omega t plus phi, right? This is for current. Yes or no?
Yes, sir.
Now, can anyone draw it for this thing? I'll draw this angle a little bit smaller so that at least the remaining diagram will fit. Otherwise, it will become difficult. This is your I naught. And this is omega t plus phi. अरे नहीं, do it on this only because अभी एक reason और पता चलेगा. Phi, I told you कि let's say current is basically what, phi is basically the phase with which the EMF leads, right? Now, can anyone draw what will be the phasor for VR naught? Will VR naught lie in the same line as this? Will VR not lie in the same line as of the current? Because they are always in the same phase, the resistor, right? They are in the same phase, right? In the case of capacitor, can you see, in the case of capacitor, it should lie minus pi by 2. So basically, VC will come over somewhere over here. VC will come over here. Yes or no? I'll draw it a little bit big. इसके पीछे का भी reason you'll get to know soon. So can everyone see this VC naught phasor? Yes or no?
Yes, sir.
And similarly, can I draw a VL naught phasor as well? Can you see in this diagram clearly I have made VC naught greater than VL naught? Can you see in this diagram I have made VC naught greater than VL naught? Sir, what is the reason behind you doing so? The reason is very simple, I'll tell you. Guys, are you drawing along with me now? Pakka draw karna hi hai na?
Yes, sir.
So till here, please draw it. This is the phasor diagram at t equals to 0. And I'll tell you the reason why exactly I did so. So at t equals to 0 itself, can you see over here? this angle is pi by 2, this angle is also pi by 2. That implies these VC naught and VL naught are in the same line, right? Because 180 degree. Are they in the same line? Guys, are they in the same line?
Yes,
Hi,
sir.
Anna. Since they are 180 degree, the angle between them is 180 degree, so they are lying along the same line, right? But in opposite direction. Yes or no? So can I just add these two vectors just like what I did in the case of vectors, right? So when I add both of them, Control C, Control V. When I add both of them, can you see VC naught was greater than VL naught? So ultimately what will happen? This VC naught will get vanished, right? And this vector which was initially long, it will become a little bit short. So I'll draw this. And what is the length of this remaining vector? It is basically VC naught minus VL naught. Yes or no? Array, is this clear?
Yes, sir.
Since they were in the same in the opposite direction, so I subtracted them and I assumed VC naught is greater than VL naught. Now can you see, I can, this VR naught is also in volts and this thing is also in volts, right? Are both of them in volts? If both of them are in volts, then can I do this particular thing? Can I take a resultant of these two? Can I take a resultant of these two vectors? Can I take a resultant of this VR naught and VC naught minus VL naught? Can I take a resultant? Tell me yes or no. Since they are vectors, right? And we know how to solve for vectors, right? So when I take the resultant of these two, then the net thing should be equals to basically what? The phasor of it. Okay, this should be the net EMF. The net EMF should be in such a way that when you draw the phasor of this E naught, it shall divide into two parts. One part should be VR naught and one part should be VC naught minus VL naught. For that, VL naught should act in this direction, VC naught. So basically it's just the reverse engineering of this. How we went from the the initial to this, no, it's just the reverse engineering of whatever we do. Are you getting my point? So can you see in this diagram clearly, since when I have taken this particular thing, then I am getting the value of phi as positive, then only the current is leading this particular thing, right? Ab if suppose VC naught ki jagah pe VL naught would have been bigger, then this vector would have, it should have light somewhere over here, right? Yes or no? If a VL naught is bigger than VC naught, then this vector which I have drawn in the downward direction shall be drawn in that direction. And then when I'll take the resultant, then then this will be the resultant E naught, right? But can you see E naught's equation is not having certain angle. E naught's equation was basically sine omega t with no phase at all. So that is why to make that equation work, we need to take this assumption in mind, that the value of phi will be positive only. This will be the diagram only will be the case when VC naught is greater than VL naught. Is this clear? Or is this clear? Now from
Yes,
this
sir.
phasor, can you see a triangle, clear triangle over here? If this is VC naught minus VL naught, this length is also the same. So everyone can see this triangle, I guess. This angle was phi, this angle was I naught, but I don't want I naught, I want VR naught. So this was VR naught vector, this was E naught, and this was basically VC naught minus VL naught. This angle is 90 degree, and I think you people can solve it. Can you give me a relation? Can you give me tan phi? What is sorry, can you give me this particular thing? E naught square, since it's a right angle triangle, will it be equals to VR naught square plus VC naught minus VL naught square. Can I give this equation by Pythagoras theorem?
Yes, sir.
So by Pythagoras theorem, this is the case. And if I do this, can you see over here the relation very clearly? This triangle which we have made is basically the voltage phasor triangle in, this is basically called as the voltage phasor triangle in RLC series circuit. Is this clear? And from here, can you see, you can calculate the value of E naught. You can calculate the value of E naught, but generally E naught will be given. These will be, you need to find out. So can I write this thing as I naught? I naught is basically the peak value of current. Can I write, guys, this particular thing VR naught is basically equals to what? I naught into R. VL naught is basically I naught into XL. Do you remember what is XL? XL is basically the effective resistance. किसी को याद भी है? We already did this XL and XC. Does anyone remember? Ayana? So I naught into XC. So we can write this thing over here. I can write this thing as I naught R whole square plus I can write this thing as I naught XC whole square. Sorry, I naught XC minus I naught XL. When I solve this particular thing, I can get I naught as constant, I naught constant, and I can write E naught is basically under root of I naught square, and here I'll write R square plus XC minus XL whole square. Can I write it like this? And from here, can I write it like this? E naught is equals to I naught into under root of R square plus XC minus XL whole square. Can I write it like this? Yes or no? Can I write it like this, guys?
Yes, sir.
Now, can you see this particular term which I am getting over here? Under root of R square plus XC. If this would have been just a single resistor, then this would have become Ohm's law, right? So here, people define a new term which is basically called as impedance. People define a new physical quantity which is called as impedance, and it is denoted by Z. What is impedance? Impedance is basically the effective resistance of the whole RLC series circuit, or a whole circuit you can write. It's up to you. Sir, what is the need of defining another term? So first you did resistance, then you did reactance, and then you are doing impedance, right? Is the resistance and reactance, are they the same? Although they are measured in ohms and everything, but are they the same? No, right?
No, no, they're
So
not.
basically, how can you add two different vectors which are having different nature? This is having resistance and this is having reactances. You can't add them directly, right?
Yes, sir.
So that is why we have to give a new physical quantity, which is basically the summation, the vector sum of, or basically the phasor sum of R and the net reactance, right? So that is why we have to give a new this thing, and this Z is basically equal to E naught divided by I naught, which is basically equals to under root of R square plus XC minus XL whole square. Is this clear? So please remember this definition always. Z is equals to under root of r square plus xc minus xl whole square. Either you can remember it like this or you can square it. Z square equals to r square plus xc minus xl. It's up to you. However you want to remember it, but please remember it. If you don't want to remember it like this, then you can use this triangle as well. Suppose it's like make a knuckly triangle. Always remember the direction of Z will be in the direction of current, right? If I want to draw the phasor of this particular thing, then the direction of Z will be always in the direction of current, and current was not over here, current was over here, right? Current was at an angle phi at t equals to 0. Okay, so always remember Z will be over here, and for this to be here, right, xc over here and xl over here and r over here. Okay, so can you see xc xl is a little bit small, so xc minus xl will come over here, and then you can take the whole impedance. Anyways, this is basically called as an impedance triangle, but we'll learn about it later. For now, is this two formula clear? Are these two formulas clear guys?
Yes, sir.
Anna? Z, this is the formula for net impedance of the circuit. Very important, because all of the problems on AC will be solved with the help of this formula and one more formula which I'm giving. Anna? Now in the second diagram, can you see over here, if I try to do tan phi is basically the perpendicular upon the base. The perpendicular is this and base is this. So from here, can I write also the value of tan phi is equals to VC naught minus VL naught divided by VR naught. Can I write this thing as I naught comma common XC minus XL, and I can write I naught into R, I naught cut marega. So tan phi is also equals to XC minus XL by, and from here you can do tan inverse, right?
Yes, sir.
So basically tan phi is equals to xc minus xl by r, and z square is equals to this. With the help of these two formulas, or if not this then that, with the help of these two formulas you will be ruling the whole AC thing. Clear? Is this clear guys?
Yes, sir. Anna? Acha, always remember, if I want to do cases, if xc is greater than xl, then what will happen? If xc is greater than xl, then the value of phi will be Positive.
and if xc is less than xl, then phi will be.
Negative.
And what will happen if xc is equals to xl?
Phi 0.
It has a physical meaning. We'll talk about this particular thing. Acha, what if there is no resistance, if R is 0?
Then phi is 90.
Phi is 90 degree, and that too when you assume xc is greater than xl, right? Yes or no? And phi is minus 90 when you assume xc is less than. So on the basis of that tan phi formula, we did all this. Please write it.
Done, guys. Please remember those two results. Note, please write the two results are again valid if we try to write in terms of RMS value. In place of writing the peak values, if we write the RMS value also, then also those results are in spite of writing मैं पूरा RMS के terms में लिख देता हूँ. Virtual value की जगह पे I'll write the whole RMS thing. So ERMS square is equals to I VR RMS square plus VC RMS minus VL RMS का whole square. So can you see this is the same thing? In spite of writing not, I am writing RMS. And similarly, tan phi is equals to VC RMS minus VL RMS divided by VR RMS. So the same formulas I can write it again. Please remember also this particular thing here. VR RMS will be basically equals to what? I RMS into R. Similarly, PC RMS will be basically what? I RMS into XL. In place of I naught, I have written what? I have written RMS. That's it. That's the only change which I have done. So I RMS into XL. Also, XC ka formula everyone knows. What is XC? XC is equals to 1 upon omega C, and XL is basically equals to omega into L. Everyone remembers this. Hi Anna. Clear hai kya, guys? Alright, is this clear?
Yes, sir.
Yes, sir.
So with this thing, acha, please remember also this particular thing. It's not necessary that always this RLC should be present. है ना? If any one of the circuit is also missing, no, then you just substitute the value as it is. अब suppose for example, if resistance is missing, then in all those formulas you will put R equals to 0. If R will become 0, then VR will become 0, right? So it will become just basically this. Hi Anna. Yes or no, guys? Similarly, if inductor is missing, it will become a RC series circuit across alternating source, and if capacitor is not present, then it will become, if the capacitor is not present, then it will become
0.
Capacitor is missing, then capacitor should become infinite. Why capacitor should become 0? Because XC should become 0. I'll write it. ये शायद से conceptual question है. It might trick you somewhere. If any one element of the circuit is missing, then first part, if resistance is missing, then it's easy. Then you'll just consider R as 0 and everything will be sorted. When inductor is missing, if there is no inductor in the circuit, it's just a resistor and a capacitor connected across an AC source. If it's like this, then what will you do? You'll consider XL as 0. If I consider XL as 0, then omega L is basically how much? 0. And from here, can you see L is also 0, right? And please remember, if capacitor is not there, that you know, it doesn't mean that capacitor is missing. If capacitor is not present, then you know the current will continuously flow through that wire, right? If capacitor is missing, conceptually see guys, if capacitor is missing, then current will continuously flow through the wire, right? Hello people.
Yes, sir.
So suppose you have a capacitor and not here in this case, if you suppose you have a resistor and a inductor over here. Now suppose I have covered this thing with a box. I don't know what exactly is inside, but if there is no capacitor over here, then that implies current will keep on flowing, right? Current will it ever become 0? Guys, will it ever become 0?
No,
Current
sir.
can never become 0, no? In this the particular capacitor की वजह से, मतलब in the previous case capacitor की वजह से the current was becoming 0, right? So here you will not say the capacitance is 0. Here you will say that the effective reactance due to the capacitor is 0. If that is 0, that implies 1 upon omega C is 0, and for that C should be equal to infinite. If there is no capacitance over here, then you'll never say, like, you remember this question, suppose if there is a plate of capacitor and a current is flowing through a direct current, and if I connect these plates with a wire, then what will be the capacitance of this thing? Will the capacitance be 0 or will the capacitance be infinite? You remember I made you solve this question in capacitance. So the capacitance is never 0 in this case. It's not 0, it's infinite. Why? Because the current keeps on flowing, and you believe, like, you know, the charge is getting stored. Although none of the charge is getting stored, right? All the charge is flowing because you have connected with a metallic wire. So all of the charge is flowing. But do you know that what is happening inside this thing? You will feel like, sir, from like past 1 hour I am giving it charge and it is keeping on storing. So hence you will not say the capacitance is finite, you will say the capacitance become infinite. So the same reason applies over here as well. Is this clear? So that's it for today's class. In the next class I'll teach you how to draw the impedance triangle, and then we'll do some questions. After those questions, the complete class will be on questions only, and then we'll discuss the power and resonance part. No, I think it will take 2 more classes, and this easy chapter will also get over. Okay, okay guys.
Yes, sir.